Hello, I'm Sean Powers. I haven't made a video in over a month. Let's change that now. Now, you probably thought that I fell off the face of the earth if you haven't been following me in other places, but I have not. And so let's continue where we left off on the Linux Plus exam. And what we're doing now is this section of section 1.2. I'm going to call this file formatting, and we're going to look at three tools. I know this seems like a tiny little bit of stuff we're going over, but it's because these are pretty complicated little beasts. And we're going to go in this order. We're going to go PRINTF, and then we'll talk about SED, and then we'll talk about AWK. And basically, these are just ways to manipulate text into a format that you want, or to extract data in a way that is useful for your particular needs. And again, this is just a tiny part of a big section, so we're not going to go too deep into each one of these tools. I'm just going to get you started on how they work, and then hopefully you'll keep playing with it, learning more, etc. We're going to have a weekend assignment if you want to do a little more complicated test. I'll talk about that at the end. And we're just going to learn the basics now so you can expand from there on your own. But honestly, what we're covering today is probably going to be more than you will be asked on the actual Linux Plus exam. I just don't want to guarantee that because you never know how deep they're going to go on any one topic. Anyway, let's get down and get started with PRINTF. And PRINTF is print with formatting, I guess. It's kind of like Echo, except you can format the output on one line. And if you're a programmer, you're probably already familiar with PRINTF. It's used in a lot of different programming languages, but Bash actually has PRINTF built in as well. So you can use it in your Bash scripts or right on the command line. We're actually going to do it right on the command line so you can see the output right away. And I know this slide is a little on the intimidating side, but basically how PRINTF works is you type the command and then the format that you want the output to come into, and then the argument, meaning the actual text that you want it to manipulate, whether that is a variable or a file or a bunch of text put right on the command line, which is what we're going to do for simplicity's sake. And the format can come in just a huge array of things that you can do. And I'm going to cover these just briefly here, and then I'll show you what I mean, because it's easier for me to learn stuff while we're doing it. But things like \n will do a new line because PRINTF, unlike Echo, doesn't return the line. If you want to tab, you can do \t. And then when we talk about formatting specific types of data, the three we're going to look at are integers, floats, and strings. Now, there are more. There's like characters and stuff like that that you can format using PRINTF, but these are the basics, and that's what we're going to cover. And then specifically, you can not just like specify a string, but you can manipulate those strings or those integers or those floats using numbers. Like we put a instead of %d, like this is just %d, this is %3d, and that is going to put the output into a 3-character block, right justified. We can, if we do 03D, it's going to do the same, but it's going to pad it with zeros. Don't worry if you're not following along really quickly. I'm going to demonstrate these as well. And the same thing with strings. We can actually say how many characters to print out, and then whether we want to right or left justify them. And then even with floats, meaning like a decimal number, we can specify how precise those decimals are, like how many decimal places it will show us. Like by default, it shows 6, but let's just go to the command line and look at it, because this screen is just boring as heck. So I'm going to go kind of lightning fast here, because a lot of this is just like Echo. So for example, if we do printf and then we just put something in quotes here like hello world, it's going to return it. But remember I said it doesn't do a new line like Echo does. So if we wanted to actually just do print hello world to the screen, we would do printf hello world, and then we would do a \n for new line character, and then it will say hello world and give us our line back. I mean, that's not terribly useful. We could just use Echo for that. But let's say we did, and also you'll notice I didn't specify any arguments. I didn't have it do any formatting. I didn't replace it with like %s for string. That's what we're going to do now. So now we're going to add that argument part to the printf statement. So let's do printf %s, which means the string. I want you to format the argument I'm going to give you as a string, and then \n, put that in parentheses or in quotations, and it should just give us the string that we give it as an argument as a string with a new line character after it. I know this still seems pretty simplistic, but it'll make sense in a second. And then let's do hello world, and we're going to see a problem right away. hello and then world on the next line, and actually iterated through them because we gave it 2 arguments and there was only one specification right here, like this 1%s. There was only one reference to one of the arguments. So it actually thought, oh, you want to do this to the words hello and to the word world. If we wanted it like it was before, just on one line, we would have to make hello world a single argument. So we would, just going to hit up arrow, we would do that same thing, but then we would put hello world in quotations itself, and that makes it a single argument instead of 2 arguments. Now we should just see hello world on the screen, which is kind of what we expect exactly, right? What I'm going to do now is just give us a little bit more format so we can see what's actually being printed. So hopefully this makes sense. If I do printf and then I open quotes and I just do a less than, or a left bracket, this doesn't have any meaning as far as printf is concerned. So it's just going to print that left bracket for us. And then I'm going to do %s, which will say, you know, that first argument as a string. And then I'm going to close the bracket and then I'll do a \n. And now if we do just the word hello, that single argument should be inside of those brackets. Let's see. Sure enough, hopefully that makes sense, right? All I did is I put those brackets around there and it substituted our argument hello into here at the %s. Now, the reason I did that is because we can also do spacing with printf. We can format it to be a specific number of characters. So we can do printf. I'm going to do these again just so we can see the spacing as it's in there. And if we do % and then put the number 10s, close the brackets just for visibility's sake, \n, and now I say hello, it's going to put our word in there, our string in there, but it's going to be 10 characters long, and it's going to right justify the word hello in those spaces, right? It's going to right justify it. If we wanted it to left justify, we could do the same thing, but instead of 10s, we would do -10s, and now we should see the same thing, but it's going to left justify it. And now again, those brackets, they are not part of the justification process. I just put them there so we could see it actually happen inside brackets. Now, it is important to note, though, the 10 characters is a minimum. It sets a minimum of 10 characters. But if we did something like, so I just pushed the up arrow, and instead of just the word hello, what if I said, hello, Mr. Fancy Pants? This is going to expand it out so that the entire thing is in there, even though it's clearly more than 10 characters. 10 characters is the minimum. If we wanted to limit it to 10 characters, like we wanted to truncate it down so it could only fill the 10 characters, then we would do the same exact thing. So I'm just pushing the up arrow, so I don't have to type all that out again. But then back here, we would do .10s. So %.10s, and this is going to truncate it at 10 characters. It's going to say, okay, stop at 10 characters. And that's what we get. We get hello, mist. Cut it off because we said it has to stop at 10 characters. That's what the dot does. So we're basically just formatting the output of whatever it is we feed into the printf statement. But it doesn't just work for strings. We can also do this with integers. So for example, printf %d and \n just so that it gives us a new line. And now we can just say 43. So that's going to be our argument, is the number 43. Boom, it prints out 43. Not terribly exciting, but what if we did this? What if we said printf %5d \n, just so we get that new line, 43. Now, what do you expect to have happen? Again, these work similarly, but it's new, you know, it's slightly nuanced when it comes to numbers instead of strings. Here, it does the same thing. It right formatted it. Like if I would have put the brackets there, we would have seen that there are 3 spaces in front of it. And basically what we've done is just right justified in a 5-character field, the number 43. That isn't as useful when we're dealing with numbers so much. I mean, we definitely like to right justify numbers, but I mean, that doesn't, I don't know. I prefer when I have numbers like this that I want to have fill up a certain number of characters, I want to pad them with zeros. And so if you remember that slide, we can pad that number as well. We can do printf %05d, and that's going to pad it with zeros up to that 5-character limit, and it should pad the front. And then let's see, \n, so we get a new line, and we'll go with 43. Sure enough, it padded it with zeros, and that gives us the 5 characters, but again, front padded with zeros, because of course numbers with zeros in front of them are the same. So 43 and 00043 are the same number. And one last thing I want to look at is to format floats. Now floats are decimal numbers basically, and it won't work if we try to use a decimal. So the /d for integer, I mean. So if we do print F, and then let's do the same exact thing, but then I say like 0.7, so 43.7, it's going to be like, whoa, that's an invalid number. Now it did give us the answer as well, but it only gave us the integer part because 43.7 is not an integer, and it did tell us like, dude, you screwed up, okay? And so if we're dealing with decimal numbers, we want to use the F or %F in order to manipulate those, and we have a little bit more flexibility there as well. So print F cent F \n again, so we get the new line 43.7, and this should give us 43.7 formatted as a float because we use that %F. And sure enough, 43.7, and now you'll note by default it uses 6 decimal places. Okay, so 7 and then 5 zeros because it uses 6 decimal places by default. And that's fine if you don't care like how many decimal places there are, but we can change that as well. We could specify, let's see, printf. I'm going to combine a couple of other things. Hopefully we can do these without individual steps here. So %, and I want to do 0 to pad it with zeros. And I want 10 character places minimum. So 10 character places, F as a float, and then \n for a new line, and then 43.7. Now let's see what this does. What I'm doing now is I'm formatting that first part, that 43, and we should get, sure enough, we should get 10 characters because we limited it to 10, and it did 0 pad it. But this is something I want you to pay close attention to. We have 1, 2, 3, 4, the decimal counts as one of the characters, 5, 6, 7, 8, 9, 10. So 10 total characters, but that decimal counts. And it did pad with that 0 in front because without it, there were only 9 characters. But we can also tell it how many decimal places we want to use. And so it really starts to get kind of complicated. So printf, and I'm going to do %, and I'm going to stick with the 0, 10, so it pads in 10 total places, but this time I want to do dot only 2 decimal places. Okay, so hopefully that makes sense. I've told it I want 10 total characters, I want to pad it with zeros, but I only want 2 decimal places with my float, and then I'll do the \n, and we'll keep the same number. Now, what do you expect to see? I hope to see more padding of zeros because we don't have the 6 default decimal places anymore. Now we only have 2 decimal places, so it should have to pad the front with zeros more. And sure enough, we have 0000043.70 because we specified 2 decimal places. Now, I know that was a whirlwind of printf, but hopefully you can go through those same sort of examples that I did, play with it, see if what you type out is what you expect to see when you type it. And like I said, I just put the arguments at the end, but those arguments can be inside of a bash script and they can be a reference to a variable. So you can use it in a script and then have it format the variable instead of just a quoted chunk of text as your argument. But that's how printf works, and it just formats what the output looks like. I especially like it when it comes to float variables or float numbers, because I like to specify how many decimal places and that sort of a thing. Now our next command, I know the screen looks intimidating, don't worry. Our next command is SED, or Stream Editor. And what this does, we say SED, and then we give it options, we give it the script or what commands we want it to run, and then we give it the file or the input, the text that we want it to work on. Now this can be a file name, it can be standard input, so we can pipe something into SED and then get results that way. But basically there's these parts. There's the command itself, and the options, which are these in the same color, and then the script is like the transform that we want done on it, and then where to get it is this last variable. If you don't pipe it in via stdin, then it's a file name, and that's what it does the transform on. Now, by default, SED will print out all of the results to the screen, to standard output. If you don't want that, and I'll show you why that would be something you might not want, you do the -n, which means don't print everything. -I means that we can edit an actual file in place. So SED Stream Editor will actually edit a file, and you can even create a backup of the original file. But I almost never, in fact, I don't think I have ever used SED to actually edit a file. What I will do is I will read the information in, and then I will take SED's output either into a file or pipe the output into something else if I'm doing like a long string of things. I don't like to edit the actual file in place. With SED, I really just like to have my original file stay how it is, and then whatever the output of SED is, do something with that. That's just my personal preference. SED can, in fact, edit a file in place, and that's the -I, and it'll make a backup if you do -I and then a suffix so that it knows what to save the backup file as. It just seems like a way to get into trouble, so I don't normally do that. But then once you have told it its options, if there are any, then you go into what you want it to transform. Like, for example, a number with P means print out that line, so like print out the 17th line, or print everything but the 17th line. If you do D, that deletes the 17th line from the output. You can actually do things like delete all but a certain line. The D and the P is either print or delete, and it's basically either show it or don't show it. Usually, if I'm using SED, I'm doing something like this. I'm substituting, and so in the script part here, after you do the options, you can put your script of like substitute thing 1 for thing 2, and it'll basically go in and substitute the first occurrence on every line that it finds thing 1, it will substitute that with thing 2. If you want to do not just the first occurrence on every line, but every single one, then you add a G for global at the end. We're going to demonstrate this in a second, so don't get too stressed out. And then I'll show you this like really cool example of how you might actually use it, and it is to like remove all the commented lines from a configuration file if you wanted to see the output without that. So anyway, let's actually do it again. Okay, and in here I have two files, file.txt and nsswitch.conf, which we're going to look at the very end. Let's look at file.txt just so we see what we're looking at. And this is just a file, a text file with a few strings here. This is a chicken, this is a fish, this is a fish, this is a chicken fish, this is just text. It'll make sense in a second why it's a ridiculous couple of lines like that, but this is the text file that we're going to manipulate with SED, okay? Now the first thing I want to show you is if we could just do SED and no options, okay, so there's no like -n or anything like that, so no options, and we go right to the script part, like what we want, what transform we want done, and we just do quote, so like no transform, and then tell it what file, file.txt, we should see the original file with no transformation. And sure enough, that's exactly what we see. So if we do nothing to the file, SED will just show us the intact file as it spews it out at the end, okay? But if we wanted to do a simple transform, so we could do something like SED, and again, I'm not doing any options here. I'm just not using options. I'm going right to the script portion. We can do 2D, file.txt, and what will you expect here? So remember, D means delete, and we're telling it to delete line 2 from the output. So now it should print everything to the screen except line 2. And sure enough, notice there is no, this is a fish line, it's just not there, it's deleted, okay? Now, if we can do the same exact thing, but we could print it instead, and now you're gonna see where commands, or where the options come into play, because I'm gonna, I don't wanna clear the screen, I wanna compare. So if we do SED to P for print line 2, file.txt, would you just expect to see the second line? Well, you're going to see more than that. In fact, what you're going to see is the second line twice. Now, if you're thinking, what the heck just happened? Remember, by default, SED prints out everything that it processes. It prints out everything that it processes to the screen, and then we told it we also want it to print line 2. So it printed everything that it processed, and then it printed line 2. So it actually showed us line 2 twice, because the first time it was just as it's displaying the output of itself, you know, it's processing, it shows us, and then it displayed what we told it to. So that's where, if you only want to show a certain line or certain lines, you would do -n, and -n means no showing the output of the file as you process it. Okay, don't show me anything unless I tell you to. And that's where we would do like SED -n 2p file.txt, and then we only see line 2 printed out because that's what we told it. We said no output, but then we said the transformer I want you to do is to print line 2, and so it did. That's usually what you do. That's the difference between the D and the P, like either to delete a line or to print a line. You have to think through what you're doing, and it's usually trial and error to remember when do I put a -n, when don't I put a -n, and that sort of a thing. And now that was just deleting lines and stuff, but remember, what I usually use SED for is a quick transform or substitute. I'm sorry, not transform, a quick substitute. So I would do something like SED and then substitute fish for dog, okay, out of file.txt. And now it will print the output, but it will do that substitution as it prints it out. So press enter. What did I do? Oh, duh. Okay, sorry. Forgot the closing slash after dog. Anyway, so substitute fish with dog, and it will display on the screen everything, but it substitutes dog in the place of fish because we told it to substitute every occurrence of fish with dog. And does that line up? It says this is a chicken. Yeah, this is a dog. This is a dog fish. This is a chicken dog. So everywhere there is fish, it substitutes it, except what about this fish? Well, if you remember I talked about it in the beginning when we looked at the slide, that by default it will only do the single occurrence on each line. If we wanted to do all of the occurrences in all of the lines, we have to add one more flag. So we would have to do SED, substitute fish for dog globally. So G is globally, means do it for all of the occurrences on all the lines. File.txt. And then now it will say, this is a chicken, this is a dog, this is a dog. It did both of the occurrences of fish, and that's how it substituted that out for us. Now, I have given you basically what I use SED for, simple substitutions like that in line. Usually it's with a whole bunch of pipe commands into like another SED into another SED sort of a thing. But something that is a useful thing that I also sometimes do is, let's clear the screen and we'll see we have this other file, nsswitch.conf, okay? If we look at that, this is just out of my etc folder. This is just a configuration file that talks about how the naming service does stuff. It's not important what this is for right now. We'll probably learn about it later in Linux Plus. But basically what I want to show you is how you would get rid of commented lines, because sometimes with a really long configuration file, there's so many comments, it's easy to get lost. So what if we wanted to strip out all of the comments on this command? Well, we can do that. There's a way we can do it, and then a way we can make it more awesome, if that makes sense. So first of all, we would do SED, substitute the pound symbol or that hashtag, that first character, and then we're doing a little bit of regular expressions here. So dot star, which means followed by any number of characters. And then I want to substitute it with, and here's where it gets funny, watch close, nothing. I put a nothing in there. So what it's substituting, anytime it finds a line that starts with that, it's going to substitute it with a nothing because I put nothing in between there. Okay. And so it will substitute it with nothing for the file nsswitch, but there's a problem here. If we do this, we're going to see, sure enough, all of those comments are gone, right? Well, that's awesome. But now what? Well, now we have a bunch of blank lines, and we actually didn't want just blanks, right? If we wanted to get rid of blank lines, this is something that I would do. I would say, oh, that's right. So now we have all the blank lines. So what I'm going to do is pipe that output into another SED statement, and that SED statement, because I have to do I have to do a little bit more regular expressions. So I'm going to do -e for regular expressions, and then I'm going to define the beginning of a line, end of a line. So any line that has the first character that is the beginning followed immediately by the end. Again, this is regular expressions. So anytime you do that, I want you to delete. This is just like when we said delete line 2. Anytime that we match that pattern, I want you to delete it. Hopefully that makes sense. Instead of saying like delete line 2, I'm saying anytime you find this pattern, and this pattern in regular expressions is the beginning of the line immediately followed by the end of the line, I want you to delete it. And now, hopefully, we should see just all of the actual configuration thing. Let's see. Sure enough, it worked. It mushed everything together with no comments at all. Now that might have been a little bit intense, and I apologize if that was more than you were bargained for, but that's kind of the kind of thing that I actually use SED for on a regular basis, so I wanted to give you a real world example. And I know this is getting to be a long, complex video and your brain's ready to explode, but we have one more to cover, and It's both the most complicated of these text manipulation tools, but also the one that we're going to dive the shallowest into. I don't want to show you everything AWK does because that's a whole series on YouTube. Basically, I want to show you the thing that people use AWK for the most, and that is to separate fields in text, like a comma separated values, or like tab separated, or a word like spaces between words. So let me show you what it is, and some quick examples, and then I promise we'll be finished with this video. Now, AWK works the same as the other tools that we've been using. Basically, you start with AWK, and then you give it whatever options you have. They don't have to have options, but if you have options, they go next. And then you either give it the name of a file or standard input, and it will run its manipulation on that. Now, I'm only going to talk about one option, and that is -F, which sets the field delimiter. So like by default, its standard delimiter is the space. So like if you have a sentence with a bunch of words, it will treat every word as an individual field because it's separated by a space. If you have a comma separated file, though, it's not going to recognize those fields unless you specify like -F comma, and that tells it, okay, the fields are separated by comma. So by default, it uses space if you don't have any option there. But if you have a comma or something, you would use the -F, capital F option, and that would tell it what your field is. And basically, this is the format. I'm going to use standard input instead of a file because I've been using files a lot, but I'm going to use standard input. So echo, hello, you meaty human. I'm going to echo that to the screen. I'm going to pipe it to the awk command, and then awk is going to take that, and I'm going to tell it, I only want you to print the third field. So that's what this is. We put the arguments in single quotes, just like we did with SED, and then we do open curly braces. We tell it print $3, and that will tell it the third field, and we close it and, do that thing there. And so then the third field that it finds, it will print out. So hello, you meaty, we would expect that it would print out the word meaty, because when it separates up the fields by the spaces that it uses as the default separator, that would be the third field, and so it would print that out. It's really useful when you're trying to dissect like a comma separated file, and that's partially what our weekend assignment is going to be if you decide to participate in that. But anyway, let's go to the command line again. We're going to cover this one the least heavily, but it's actually one of the ones I use the most often. Oh, I guess I should say too, it took me a long time. I assumed that awk stood for something. All it is the last initials of the 3 developers that wrote the original program. So awk is just their name, AWK. I don't remember their names, but it's just initials. It doesn't actually mean anything at all, which is kind of nice to know. Anyway, again, we're just covering the very basics of what awk does, but if you want to learn more about awk, you can certainly do it. It does all sorts of text transformations and manipulations, but this is the one that is the most commonly referenced, and almost certainly if you're quizzed about awk, it's going to be something like this. So let's just do that example that we talked about in the slide. Hello, you meaty, what did I even say? Hello, you meaty human? I think that was it. And then I'm going to pipe it into awk. And since the default field separator for awk is space, I don't have to give it any options. And then what I want it to do, I'm going to put it into single quotes, open braces, print, not pring, print $3, close curly braces, close single quotes, and this should just tell us meaty. Sure enough, meaty. That's exactly how it worked. But we could do, if we have something a little more, not just a string of text, but like a comma separated values, right? That's something that we often use. We could do something like, let's say we brought in a comma separated file of hello, comma, you sexy beast. So it's now comma separated. And, if we just press enter, it's going to print it to the screen, right? So we want to pipe that into, now if we did the exact same thing, print $3, we're not going to get any output, because as far as awk is concerned, there's only one field, because remember, by default, its field separator is space. There's no spaces, so it's like you only have a $1, right? And so it's not going to print anything. But if we were to, I just pushed up arrow and then do -F comma, Now we're telling it the field separator is comma, and I didn't put a space there. You could put a space there. It's really user-friendly in that regard, but I usually just do -F and then immediately following the F, what my field separator is, and now we should see sexy, because that's then the third field is sexy. Now we can do other things. We don't just have to print out one field, although honestly that's usually what I end up doing. But what if we did, instead of just print $3, we could say print $3, and so then we could say then print a space. So we just put a space in quotes, and then after the space I want you to print $4, and then after $4 I want you to print an S immediately after it, and then I'm going to close the curly braces, close my single quotes. So what do you think this will do? So what I've done is I printed $3, which is going to be sexy, and then I printed a space, so it should print a space. It has to be inside here. It's not going to print this space. It's going to print this space, and then it's going to print $4, which is beast, and then immediately after the word beast, it should print an S. Just the letter S, because I put that in quotes. Let's see if we get sexy beasts. Sexy beasts. That's what we got. Whew. Do you want me to take another month off after that video? I know that was a doozy, and I just wanted to cover those 3 text manipulation tools because they're kind of related. They do similar things, and I like to string them together using the pipe symbol, like, you know, standard output into one, into another, so that I can manipulate text down to exactly the data that I want to either print to a screen, or if I'm inside of a bash script that I want to assign to a variable, that sort of thing. So I put them all together in this kind of long in the tooth video so that you would be comfortable using all of those. And I'll put a link in the description to this weekend assignment if you want to look at that. It's just going to be taking a file and trying to get data out of it and create a bash script to do cool stuff. You don't have to. That's certainly not part of the Linux Plus preparation. Officially, it's just something that our little group of people here have been wanting is some assignments. We're going to do that. Also, first of all, I want to thank you. Hopefully they're on the screen now, but I want to thank all of my patrons. I have Patreon now, and these are people who are donating money to make sure that I can continue making this content and all the other content that I create. Thank you so much. In particular, Ben Klein, who is my only Bean Class Nerdling supporter. And if you don't know what a Bean Class supporter is, well, you just look at my Patreon page. Even if you don't plan on being a patron, it describes all the tiers, and he's the only Bean Class, and he's just full of awesome. Anyway, I also have another channel. I've decided this channel is going to strictly be Linux training, like right now Linux Plus, but my other channel, which is Inside the Brain of Sean, is where I'm going to put all sorts of other stuff like BirdCam projects and Raspberry Pi projects, and there's no rules over there. The YouTube algorithm will never recommend that channel to you because it's so not niche down. It's whatever I happen to be thinking of or want to put on there. So it's the no rules channel. If you want to follow me more closely, please subscribe to that. I'll put a link somewhere to that as well if that interests you. And lastly, yeah, the weekend assignment, we're going to go over that in the live stream on Sunday. I'll give you one possible solution to that. I think that's it. The only thing left to say is learn everything, do what you love, and most importantly, be kind. I'll see you in the next video. Maybe I'll see you this Sunday at the live stream. Thanks for sticking around to the very end. You're awesome.